Okay, I'm going to make this video to help you study for your Finite final. Hopefully this will prove to be beneficial to you. So I'm going to use the version 1. You should have access to this from your instructor, or it should be on your Canvas page. Either way, I'm going to put a link in the description so you can download it if you do not have this particular final exam to help you study. Judging by some of the questions, I think this might be one of the older ones. This is probably at least 5 years old, probably leaning on 8, but there's no way to know. It doesn't actually say what year that they gave this. Okay, so in this video I'm going to do the first 3 problems. So let's take a look. Okay, so again, this is version 1. And question 1 asks, a die is rolled and the number on top is noted. If the number is 3 or more, the experiment ends. But if the number is less than 3, then the die is rolled again and the number on top is noted. How many outcomes are in the sample space of this experiment? So a few things I want to mention. What are we actually looking for? We're looking for how many outcomes. So we won't have to do anything to do with probability. So whenever you're reading questions, make sure you're paying attention. What am I actually solving for? Here I'm solving for how many. This is a how many questions. How many outcomes are in the sample space? Or how many ways can this happen? Okay, let's understand the rules of the game. If the number is 3 or more, the experiment ends. Okay, well this is a normal die. So if the number is 3 or more, that means it's 3, 4, 5, or 6. Okay, that's 4 different ways. If the number is less than 3, 1 or 2, then the die is rolled again and the number is noted on top. So it's rolled again if it's a 1 or 2, and then we roll again, so that would be 1 through 6. So there's 2 ways this can happen, and there's 6 outcomes after that, so that would be 12. And then here we still have this 4, then 12 plus 4 is 16. Let's take a look at the tree and make sure that makes sense. So here's the beginning of my experiment. From the rules of the game, I made this where if it's 1 or 2, then we roll again and I can get a 1 through 6. So that's 2 and then 6, that's going to make 12. And then here, if I get a 3, 4, 5, or 6, the experiment ends, so that's 4. So the answer would be 12 plus 4, which is 16 different ways that this can happen, or there are 16 outcomes in the sample space. Okay, so hopefully that helps you solve that problem. Alright, question 2. The Lake Wobegon City Council must name 3 new streets. The first is to be named for a tree, birch, maple, or oak. The second, a president, Washington, Lincoln, Roosevelt, or Truman. And the third, an author, Shakespeare, Dickens, Capote, and Robbins. How many ways can the streets be named? Alright, so a few things I noticed about this. Again, this is a how many question. Has nothing to do with probability. So we don't need to determine anything to do with probability, which is good because that would take much more time. Another thing I noticed is it says there's first, second, and third. That kind of seems like order matters this time. It actually won't matter for the math. Even if you used combinations, you'll still get the correct answer. But it does technically say first, second, and third. So order does technically matter. So I'm going to need to use permutations or multiplication principle, however you think about it. Strictly speaking, this would be permutation because you would only use the name once. You can't think of using oak twice and picking it once. So strictly speaking, we'd have to use the permutation principle. Okay, well the answer is really, really easy. There's 3 choices here, there's 4 choices here, there's 4 choices here. It's just as easy as 3 times 4 times 4. That's 12 times 4, which is 48. Here I have the other notation, just in case you would see this on your final. Sometimes they write it like this, where they have the little permutation, and again, all this means is 3 times 4 times 4, because we're choosing 1. So different finals, they write the answers different ways. With combinations, you'll see that they'll have that capital C. So that's something to keep in mind. Okay, let's go to the next question. A large sack contains a basketball, a soccer ball, a baseball, and a tennis ball. In drawing balls from the sack, it is observed that the basketball is twice as likely to be drawn as the soccer ball. The soccer ball is twice as likely to be drawn as the baseball, and the baseball is twice as likely to be drawn as the tennis ball. What is the probability should be assigned to the outcome the basketball is drawn? Okay, here this is probability, and we're finding the probability of the basketball. So what's the quickest route to find the probability of drawing a basketball? Alright, well, let's go back for a second and let's kind of pick this apart. So I have basketball, soccer ball, baseball, and tennis ball. I have 4 different balls, okay? And here we have relationships, okay? So a basketball is twice as likely as a soccer ball is twice as likely as a baseball is twice as likely as a tennis ball, alright? Well, I don't know what these equal, but I know that if you added all the probabilities of all 4 of them, they'd have to equal 100%. If you reach in there and grab a ball, you 100% have a ball. So if you add them up, it's going to be 100%. This is usually what's called a weight problem. Alright, let me show you how I solved it. Alright, so here I made my own little notation. This says that a basketball is twice that of a soccer ball is twice that of a baseball, and a baseball is twice that of a tennis ball. Alright, so if you add these all up, it equals 100%. I don't know what they equal individually, but I know that if you added them all up, you would get 100%. Alright, so now you have to start subbing in these variables. I know that a basketball is twice that of a soccer ball is twice that of a baseball, and a baseball is twice that of a tennis ball. 2 times 2 times 2 is 8. That means a basketball is 8 times as likely as a tennis ball. That's why I have an 8 here. Okay. Now, for the soccer ball, it's twice as likely as a baseball, and a baseball is twice as likely as a tennis ball. 2 times 2 is 4, so that means a soccer ball can be related to as 4 times as likely as a tennis ball. And then here, straightforward, baseball is twice as likely as a tennis ball, and we still have that other tennis ball in the bag. Now, everything is within one variable. That's the trick with weights, is to get it all down to a single variable equation so you can solve. So now I'm down to 15 tennis balls. 15 tennis balls equals 100%, or tennis ball is 1/15th chance. Alright, but now I have to translate this tennis ball back to basketballs. Okay, so how do I do that? Well, remember that 2 times 2 times 2 was 8, so it's going to have to be 8 times 15. 2 times 2 times 2 times 1/15 is 8/15ths. Okay, so that is why the answer is 8/15ths. That's the probability of drawing a basketball. Alright, so I hope that that was very helpful. If it was, definitely check out the second video where I will go over questions 4, 5, and 6. Okay? See you in the next video.